shown an image that looks similar to this one here that shows you that the distance between home plate and first is 90, similar to the distance between first and second and third and home base. So we know that a baseball field is in a square. With that being said, we also know that home plate is at a 90-degree angle, first base is at a 90-degree all the way through because this is a property of a square. Another known is that the pitcher's mound is 60 feet and 6 inches from home plate. So using this information, we want to solve the question, how far would the catcher have to throw it to get a runner out at second base? Now you may be sitting here thinking, how do I solve this? One way to do this is through Pythagorean theorem. So we're going to set up a triangle that looks something like this, where this is our 90 degree. And we know that we have first base here in our corner, we have second base here, and we have home plate here. And we know this because if we look at our diagram and we make a little diagonal here to second base, this triangle is this just flipped. Our first base is making a 90-degree angle. From home to second is our hypotenuse, and it's a hypotenuse here. And then we have a leg from first to home, and a leg from first to second. Now, if I look at this triangle and compare it to my second one here, I know that from my leg from first to home is 90 feet. So I can go ahead and label this as 90 feet. I also know that I already have it labeled here. At first I have a 90-degree angle, and that's because there's a 90-degree angle right here as well. And lastly, I can label my last leg from first to second as 90 degrees because it is also 90 degrees right here. Or 90 feet, sorry. So looking at this, you see that the only thing missing is our hypotenuse. So how do I find a hypotenuse? Well, the Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. So I can go ahead and say 90 feet squared plus 90 feet squared equals c squared. So what I want to do, first I'm going to go ahead and do my squares. So 90 squared is 8,100 plus 8,100 equals c squared. Next, I can take my square root. So square root of 8,100 plus 8,100 equals c. And c will come out to equal around 127.27 feet. And this is what we get. So actually, you can leave it like this, or you can change it because what is 0.27 of feet? We can change it to be in inches. So we can do 0.27 feet times, and then we have to put our feet on the bottom so that our units cancel out. We have 1 foot equals 12 inches. This will leave us in inches. So 0.27 times 12 gives us 3.24. So we can say that the catcher, so let's do this in a different color. The catcher has to throw 127 feet and 3 inches to get a runner out at second base. And there you have it. We previously just solved the question, how far would a catcher have to throw to get a runner out at second base? As you can see, a catcher must throw 127 feet and 3 inches to get a runner out at second base. And we found this using Pythagorean theorem. Now we're posed with the question, how far does a pitcher have to throw to get a runner out at second base? Maybe saying, oh no, I don't want to use Pythagorean theorem. Well, guess what? We don't have to. If we look at our diagram over here, we previously found the distance here in the blue. The distance it is from home all the way to second. And what we want to find is the distance in the red. Well, all we need to know is the distance from home to the pitcher's mound and the distance from the pitcher's mound to second to figure out this problem. And luckily we already do know that, because here, a known that is given is the pitcher's mound is 60 feet and 6 inches from home plate. So this distance right here in the green is 60 feet and 6 inches. So I can use the distance in the blue and the distance in the green to give me the distance in the red as follows. So I know 127 feet and 3 inches. Now, to be able to solve this problem, we do have to do a few conversions. So I want 127 feet in inches. So I can deal with everything in inches. So over 1 foot, 12 inches. Do some quick math, and I get 1,524 inches. Now don't forget to add in our 3. So plus 3. And I get 1,527 inches. Now this is our distance in the blue. So distance from home to second. Okay, so now we just have one more conversion left. We want to convert 60 feet and 6 inches into inches completely. So we have 60 feet over 1 times 1 foot, 12 inches. So we do some quick math here, and we get 720 inches. Now don't forget to add in your 6 inches already. You get 726 inches. And this is the distance from pitcher's mound to home plate. Beautiful, right? So now I'm going to write my distances up here. 1,527 inches and 726 inches. We're almost there. So let's solve this one. 1,527 inches minus 726 inches gives me, anyone want to do the math? 801 inches. That's how far he has to throw this. Now you may be wondering, how far is this? If you do your conversions and you have 801 inches over 1 times 12 inches and 1 foot, you will get approximately 66 feet with 9 inches left over. To answer our question, how far does the pitcher have to throw to get a runner out at second base? The pitcher must throw 66 feet and 9 inches.